Assalamualaikum. Ini ialah ahli kumpulan kami. Nama saya Nurul Nofatah binti Jaafar.
Nama saya Amira Adila binti Hamid.
Nama saya Lipa Aizin.
Nama saya Anita. Nama saya Yoshini.
Dan ini ialah tajuk kami, GTO SCR. A gate turn off transistor of GTO is a 3-terminal bipolar current control minority carrier semiconductor switching device. They are capable not only to turn on the main current with a gate drive circuit, but also to turn it off. A small positive gate current triggers the GTO into conduction mode and also by the negative plus on the gate. It is capable of being turned off. A gate turn-off transistor GTO is a special type of transistor which is a high-power semiconductor device. It was invented at General Electric. GTO, as opposed to normal transistor, are fully controllable switch which can be turned on and off by dated lead and gate lead, and this is equivalent circuit of a GTO transistor.
Normal thyristor, silicon control rectifier are not fully controlled switch. A fully controllable switch can be turned on and off at will. Thyristor can be only turned on using the gate lead, but cannot be turned off using the gate lead. Thyristors are switched on by a gate signal, but even after the gate signal is removed, the thyristor remains in the on state until a turn-off condition occurs, which can be application of the reverse voltage to the terminal or a decrease of the forward current flow a certain threshold voltage known as the holding current. Thus, a thyristor behaves like a normal semiconductor diode after it is turned on or fired. This is a construction of a gate turn-off thyristor. This is the gate turn-off thyristor symbol.
The GTO can be turned on by a gate signal and can also be turned off by a gate signal of negative polarity. Turn on is accomplished by a positive current passed between the gate and cathode terminals. As the gate cathode behave like PN junction, there will be same relatively small voltage between the terminals. The turn-on phenomenon in GTO is, however, not as reliable as an SCR thyristor, and small positive gate current must be maintained even after turn-on to improve reliability. Turn-on is accomplished by a negative voltage passed between the gate and cathode terminals. Some of the forward current, about 1/3 to 1/5, is stolen and used to induce a cathode gate voltage, which in turn causes the forward current to fall and the GTO which switch off, transitioning to blocking state.
GTO thyristor suffer from long switch off time. Well, by after the forward current fall, there is a long toll time where residual current continue to flow until all remaining charge from the device is taken away. This restricts the maximum switching
frequency to above 1 kHz. It may be noted, however, that the turn-off time of a GTO is approximately 10 times faster than that of a comparable SCR.
This is the characteristic of GTO. Reverse bias GTO thyristors are available with or without reverse blocking capability. Reverse blocking capability adds to the forward voltage drop because of the need to have a long low dop P1 region. GTO thyristors capable of blocking reverse voltage are known as symmetrical GTO thyristors, abbreviated as GTO. Usually the reverse blocking voltage rating and forward blocking voltage rating are the same. The typical application for symmetrical GTO thyristor is in current source inverter. GTO thyristors incapable of blocking reverse voltage are known as asymmetrical GTO thyristor, abbreviated AGTO, and are generally more common than symmetrical GTO thyristors. They typically have a reverse breakdown rating in the tens of volts. AGTO thyristors are used where either a reverse conducting diode is applied in parallel, for example in voltage source inverters, or where reverse voltage would never occur, for example in switching power supplies or DC traction choppers. GTO thyristors can be fabricated with a reverse conducting diode in the same package. These are known as RCGTO for reverse conducting GTO thyristors. This is the IV curve characteristic of gate turn-off thyristor. During the turn-on, GTO is similar to thyristor in its operate. So the first quadrant characteristics are similar to the thyristor. When the anode is made positive with respect to cathode, the device operates in forward blocking mode. By the application of positive gate signal, trigger the GTO into conduction state. The latching current and forward leakage current are considerably higher in GTO compared to the resistor as shown in figure. The gate drive can be removed if the anode current is above the holding current level.
The GTO can be turned off by the application of the reverse gate current, which can be either step or ramp device. The GTO can be turned off without reversing anode voltage. The dashed line in the figure shown in IV trajectory during the turn-off for an inductive load. It should be noted that during the turn-off, GTO can block a rate forward voltage only. To avoid dV over dt triggering and protect the device during the turn-off, either a recommended value of resistance must be connected between the gate and cathode, or a small reverse bias voltage, typically -2 volt, must be maintained on the gate terminal. This prevents the gate cathode junction to become forward biased, and hence the GTO sustained during the turn-off state.
This is the application of gate turn-off thyristor. AC drive, DC drive or DC choppers, AC stabilizing power supplies, DC circuit breakers, induction heating, and other low power application.
Sekian, terima kasih daripada kami Group S
GTO SCR.
GTO SCR. Terima kasih.